All right, what's up, everybody? In this video, going to be going over an example research question using logistic regression. We're going to primarily stick to this one in the RStudio. I'm going to talk a little bit about how to interpret the results and go over how we can look at the unstandardized regression coefficients, the odds ratios, and the average marginal effects, or the AMEs. But in a separate video, I'll talk about how to make the tables and how to write up the results as well. So to get started here, I already had finished the script up, but I want to make a few notes. We're going to be working with these 5 packages today. This dplyr will help us to do some recoding. The psych package allows us to get descriptive statistics. We're going to use the margins command for our average marginal effects, or our AMEs. And we're going to use the broom and the PSCL to get our pseudo R squared, as well as, or actually, one of these is the odds ratios. Uh, uh, yeah, I think this is the R squared, and this one's for um our odds ratios table. So we're gonna get started here. If you haven't already installed these packages, you could type directly into the console, install packages, room, for example, and it's gonna prompt you to restart R. So we're working with GSS 2022. So anyway, you only need to install packages once. So that's why you can type it directly into the console. But we do need a library of packages. We don't need to load them in every uh, every session. So in this video, I'm going to go through the cleaning. I'm going to introduce the project. You may be familiar with these variables with the project. We already a little familiar with the project, so feel free to skip ahead to the regression results if you'd like. But I'm going to go through um, a little bit to introduce folks that maybe a little refresher on what we're looking at here. So first we need to set our working directory, load our packages, and load our data. Um, so GSS 2022, we have around 4,000 observations. So we're going to be following these 3 steps for each of our variables that we're cleaning. So we're going to examine the variables in the coding schema using the table summary command or any of the other commands we've looked at. We're going to recode if it's necessary or warranted. We could use mutate. We could use if else. You can use case when. There's a few different ways we've looked at how to do recoding if we need to. And just as a reminder here, we're always going to recode our qualitative variables um, into dummy variables or into separate categories. And so we're always going to recode our qualitative variables, and our quantitative variables. It's a bit more of a nuanced conversation, but we'll get into some of the examples of things. But always recode your qualitative variables, and for our quantitative or ordinal variables, you need to follow make a case-by-case decision. Okay, so first here we have confidence in education. This is our dependent variable. It measures how confident are you in the people who manage education in this country, with the value of 1 being not at all, or I think yeah, 1 was very high confidence, 2 was medium confidence, and 3 was low confidence. And we created 3 different dummy variables for each of these categories. Uh, so this first command here, we're creating a variable called high CEDU, where if this condition is true, if con EDUC is 1, then high CEDU will have a value of 1. If this condition is not true, then high CEDU will have a value of 0. So it's going to create a dummy variable or a binary variable, which 0 means the condition is not met and 1 means the condition is met. And and the variable is going to be called high CEDU and based on this condition. So if we run this run the same thing for each of these 3. And then we're going to confirm we did it correct. So if this is a crosstab between confidence in education and high confidence in education, so if this recoding happened correctly, then what we would expect is that everyone who has a value of 1 for con EDUC has a value of 1 for high ECEDUC. And if they do not have a value of 1 for high CEDUC, then they will have a value of 0 for, I'm sorry, if they do not have a value of 1 for con EDUC, they'll have a value of 0 for high CEDUC. So if we take a look at that, we see our crosstab where these 3 rows are values of confidence education. These 2 columns are values for high CEDUC. So these 508 people are 508 respondents who have a value of 1 for 1 for con EDUC, and they also have value of 1 for high confidence in education, high CEDUC. So we see the same thing here and the same thing here. So this next variable here measures the type of the highest level degree that the respondent has. Notice here in my notation, I'm I'm uh, I'm including both noting every step that we're doing, and I'm also providing a little bit of some signposts here, describing where in the recoding process we are. So first we're recoding our dependent variable. Now we're moving on to our independent variables. First, we're going to look at variables related to experience with education. This is our first independent concept. The first variable we have that is within this independent concept is highest degree held by respondent. There's a range of values from 0 to 4. And we did the same thing. We're going to create some dummy variables. I also here create a variable that for less than high school degree, an associate's degree, a bachelor's degree, and a graduate degree. I'm also going to create another variable here for a 4-year degree or a college graduate, which we're going to call that for anyone that has either a bachelor's degree or a graduate degree. So the way we did that is our condition that we're assessing if it's true or not is that degree is equal to 3 or degree is equal to 4. So if either of these conditions are true, uh, so if this condition is true or this condition is true, one or the other, or both, I guess as well. Well, I guess you couldn't be both, but um, if this condition is true or this condition is true, then our college grad is going to be 1. If not, it's going to be 0. It can't be, it can't be degree cannot be equal to 3 and 4 because no respondent's going to have a value of 3 for degree and also 4 for degree. And that's because if we come over here, we were to find degree, we have to scroll and look for it. There it is. So each respondent's only going to have 1 value for their degree. So this respondent, for example, respondent number 5 has a value of 1 for degree. So they have a high school degree. High school is their highest degree attained. Okay. And we can see this here. So I'll go through. As we expected, there's a only value of 0, have a value of 1 for no high school. But yeah, each of these, I'll scroll through each one. Only 2 for associates, 3 for bachelors, 4 for graduate. Now this check here, we would expect that people have a value of 1 for college grad when degree is 3 or 4. And we see that. I didn't run this one yet. Right here, where these 866 people with a bachelor's degree have a value of 1 for college grad, and these 578 respondents have a value of 1 for college grad. So if we were to do another table with just college grad, we'll see that 866 plus 578 people have a 1 for college grad. Okay. So this next variable here measures the industry that a respondent works in. We use the use the GSS codebook to determine that the industry codes between 7860 and 7890, and they have this equal sign to say inclusive of 7860 and 7890 are industries in education, corresponding roughly to elementary education, middle school education, and college education. The vast majority of folks in this, and we can see this 7860, we can find that. I believe these are the 215. I can actually find it. GSS Data Explorer. Make sure I get the explaining right. 78. So we're looking for 7860. I believe this one is elementary school teachers. 7860. Yep, elementary and secondary school, so including high school teachers. 7870 are college and university teachers. 7880 are business and technical schools. So if we look back up here, we have 7860, 7860. There's 215 elementary or secondary teachers, 88 college faculty. It's really high. 7870, yeah. Well, that's a lot of college faculty on the survey. And 13, oh wait, that's 7890. Yeah. Yes. And 13 folks who work at technical, business, technical, and trade schools and training. So we're going to assign all of those a value of 1. And we confirm we did that correctly here to make the variable first. If we scroll up here, we're going to see the only people that have value of 1 are these folks right here. So this is the condition that's being assessed. And it's measuring if they work in education. Our next variable here measures if they have any children at all. So this first variable measures how many children the respondent has, and it ranges here from 0 to 8. So there are 50 people with 8 children, there are 112 people with 5 children, etc. This variable is going to create a dummy variable called for any children that will have a value of 1 when the condition of child's greater than 0 is true. So if they have greater than 0 children, which includes 1, 2, 3, 4, 5, 6, 7, or 8 children, they're going to have a value of 1 for any children, and if not, they're going to have a value of 0. So again, have to make the variable. So all of these groups are going to have a value of 1 for any children. Now we could have also modeled this or kept this as a quantitative variable as well, in which case we'd be predicting the effect of each additional child. The way we have it set up here by turning it into a dummy variable, we'd be predicting the effect of having any children at all on confidence in education. Our next variable here is marital status, where 1 is married, 2, 3, and 4 correspond to roughly, I believe it's like divorced, separated, and widowed. It's probably, I'll find it, marital. Widowed, divorced, and separated. So 273 widows, 669 divorced, 121 separated, and these 1333 are folks who have never been married. So we're going to combine these 3 categories here into a variable for previous married. And we're also going to use separate married and never married. So see, everyone has a value of whether they were widowed, divorced, or separated. They're going to have value of 1 for the variable prev married or previously married. This last variable here is going to measure their political, so this was the independent variables corresponding to family formation. So there's 2 variables corresponding to family formation. Similarly, there were 2 variables corresponding to experience with education. Our third independent concept is political ideology. So the first variable we're going to make is political views. So this variable here measures how close someone feels on a range of very liberal to very conservative. So if I come back here, I'll show if they think of themselves as a liberal or conservative, where 1 is extremely liberal and 7 is extremely conservative. So higher numbers on this scale here are going to indicate more conservative. Lower numbers going to indicate more liberal. So what I'm doing here is just rename this variable conservatism. And the reason I'm renaming it is just so it's easier to know what it means in the table. It just makes it easier to interpret, to remember what it is that I'm looking at. One of the key reasons that we name variables simple yet substantive as possible is so you're able to read the variable name and know exactly what it represents. So whatever you need to do to name it in a way that will help you know what it means, and ideally also your reader to know what the variable measures, the better. So there are some folks that like to have their own unique memory of variables, but for most people, the short and substantive path is the way to go. So I just renamed it conservatism. We're going to see here it's going to be exactly the same. Everyone has a value of 1 for polyviews, a value of 1 for conservatism, 2 for 2, 3 for 3, 4 for 4, 5 for 5, 6 for 6, 7 for 7. So it just confirmed that it was the same, that the variable was the same. Our next variable corresponding to political ideology is trust. This is just a generalized question of how much do you trust other people? And I'll show the thing. Do you think that other people can people be trusted? With the answers being most people can be trusted, you can't be too careful, or it depends. So notice here that this is not an ordinal variable. The reason for that is because this person, a response of 1 is the most trustworthy. A response of 2 is the least trustworthy. A response of 3 is actually somewhere between a response of 1 and 2 in terms of how trustworthy it is. So don't assume that all variables follow an ordinal scale, or an ordinal scale meaning that they have an implicit or meaningful order to the categories. So what we did here is just create a variable just for low trust. So these are people who said that you can't be too careful. When it comes to can people be trusted, they said you can't be too careful. So they have value of 2 for the variable trusts, and I have low trust. Then lastly, we have a few variables measuring someone's social position. These are what we've referred to in the past as control variables, or variables that we know play a large role in social life generally, and as such are commonly included in all of our regression models, at least according to the American Psychological Association. Um, so we're going to include some of these key variables regarding race, class, and gender. So first, we're going to have their gender, man or woman. We're going to have here their income. So notice here, income follows a very right-skewed distribution. So it's treated as a continuous variable in that they recode it, but the question is actually asked categorically. And we can see that if we look at a table. So really, it was recoded from an ordinal variable, and it was midpoint coded based upon whatever category for income this was. So for example, um, this 204.5, these 53 people, they didn't say I make $204.5 last year. What they said is I make somewhere between $1 and $500. And we just midpoint coded, or the GSS in this case, midpoint coded it to be, or it could be $1,410 something. I don't know exactly why they picked 204.5, but um, it's some conversion from a category from an ordinal variable. Either way, it has a large right skew. So one thing we could do when variables have large right skews um, is we can try to normalize the distribution by taking the natural log. Now, technically, you don't always have to take the natural log of a continuous variable that has a right skewed distribution because it won't be necessarily violating the assumption of regression unless the residuals are abnormally distributed. So there's no assumption in regression that says that the X variables have to be normally distributed. That's a common misconception. However, there is an assumption that says the residuals have to be normally distributed, and in the cases where your continuous independent for independent variables that are very highly skewed can disproportionately lead or put you at a bit higher risk for non-normal distributions of the residuals across the range of that independent variable. Um, so in this situation, it's always so some folks will say it's best practice, and I just really wanted to show an example of if there's a right skew, then we could take the natural log of it to make it a bit more normally distributed. So this is confirming that we made it correctly. It's just taking the natural log, and oh, actually, it should be. Well, actually, no one has a value of 0. Either way, we do 1 plus ln income. Uh, yeah, it's gonna be off by 1. Okay. Minus. There we go. The reason we always add 1 here is when just general practice when you take the natural log of a variable, add 1, because anyone that has a value of 0 is going to be indeterminate. You're going to lose that case. So if you add 1, the natural log of 1 will be 0. So it'll make sure we don't lose those cases. In this situation, there's no one that had an income of $0, so it didn't really matter, but I didn't want to show the wrong way to do it. Anyway, let's take a look at the histogram here of our new variable, hist GSS ln income. See here, it's a more normal skew. It's still a bit of a left skew here, but a much more normal distribution than it was before. Again, to really assess if we should model income as a natural log or as a continuous variable, we'd want to look at the residuals from our regression models, but I don't know if we're gonna get to that in this video. All right. Next, we made a variable specifically just assessing if they identify as white. And yeah, so those are our independent variables. There's 4 concepts, right? There was our dependent variable, confidence education, and our independent concepts were experience with education, which we measured through work and education and degree. Our second independent concept was family formation, which we measured by whether or not they have children and their marital status. Our third independent concept is political ideology, which we measured using conservatism and trust in others. And our fourth independent concept is social position, which we measured using gender, income, and race. So we get to our part two. We're going to create our data set with complete case information. So first, we're going to make a list of all of the variables. We want to use the recoded version of the variables here. So notice I don't put sex here. I just put man and woman. So only the recoded versions of the variables. It doesn't really matter if you want to include the unrecoded variables or the variables before you recoded them, but it can just make everything a little bit simpler. Once we slim it down to, if we slim it down to only the variables we're actually going to use in our analyses. And then this set, we're going to create a data set that only includes the variables in this list, and it only includes observations for which we have complete case information. So observations for which we have information on all of the variables in this list. So we see here we have end up with a sample size of around 957. In other words, there were not 4,149 people in the GSS um, who in the 2022 GSS, and on the 21 variables that we're interested in, we have information for 957 of them. 957 respondents gave us information on all 21 of these variables. So a reminder here, you have to be able to identify why is these two numbers different. Is it because there was a filter question involved? Was there a ballot issue? Are you using a subsample within the GSS of some type, like the GSS next? You need to be able to explain where that came from, and that requires a bit of digging that's outside the scope of this video. But I'll say for now, one thing we can check here is we can. I'll just show one. Edu. Edu. This variable was only on ballot B and C. So that's not the only reason we lost cases, because we went from 4,000 to 1,000 cases, but just that's as an example, this variable is only on ballot B and C. So we're only going to include observations or respondents who got ballot B and C. That's one limitation we're already at. And you can go through and test some of the other ones as well. But yeah, all right, so that's where we're at here. First, we're going to look at some of our descriptive statistics. This is what we're going to use to create our table or to create our table one. I run it twice just so you can see these as separate phases, but we always the reason we look at the descriptive statistics in part of our phase two is we want to confirm that the data set we created includes what we want to include and identify any glaring errors that are jumping out. So we're looking here, we see around 22 people, 22% of respondents said they had high confidence education. 56% of respondents have medium confidence education. 22% of respondents have low confidence in those who manage education in this country. So this is one of the beauty of why we do dummy variables, or again, variables that have a value of 0 when a condition is not met, 1 when a condition is met, is that it gives us a very nice interpretation of this mean. So because this variable anyone has a value of 1 for high CDU has high confidence and 0 is they do not have high confidence, this mean tells us the proportion of all the respondents that have high confidence. We can see that here if we go through. So all these people have 0, this person, number 27, has 1 high CDU. So it gives us a nice way to calculate the proportion. So most of these variables here are dummy variables. We do have we have our ordinal variable here, our conservatism. So our conservatism is measured on a 7-point scale, ranging from 1 to 7. So you can see min to max 1 to 7. Our mean is 4.15, so it's right around the middle of our scale. Our median is similarly 4. Our standard deviation here is 1.51, telling us that most of our respondents are somewhere on the conservative scale, assuming this is normally distributed, which we could assess that using a histogram. Let's show it real quick. Hist my data set. Because it follows a fairly normal distribution, we interpret this standard deviation to say that most respondents have have a value of a conservative somewhere between 3.5 or 2.5 and 5.5, which is roughly 1 below and 1 above our mean of 4.15. So remember the 68-95 rule. um, for normally distributed variables would tell us that most respondents are going to be within one standard deviation. And we confirm that with our histogram here, with most people giving a score of 3, 4, or 5. Next, we have our real income here, which our mean income is $34,000. Our median income is $22,000. This is further evidence of that right skew, right? Our mean is much larger than our median. And it's actually going to even give us a value here of our skew over here as well for that. Um, and here's our logged variable, our logged income variable down here. So this is what we're going to use to make your descriptive statistics table. I'll make that in another video. Next, we have our correlation matrix. I'm going to just run the full one here. But the big thing we're looking for with this correlation matrix, and there's a lot of numbers here, but let's go through. So first, you're going to see it can be broken into roughly 2 mirror sides. This is the correlation between high CEDU and high CEDU. Now, of course, the correlation is 1. Everyone has a value of 1 for high CEDU, also has a value of 1 for high CEDU. This is the correlation between med CEDU and high CEDU. It's negative, meaning that someone who said that medium confidence education is less likely to have said they had a high confidence education. Now, of course, these two answers are mutually exclusive, and that's part of the thing is that one of the downsides of using a Pearson correlation coefficient for dummy variables created like this, or for binary variables generally. But nonetheless, this is something that we would expect to see. So any subcategories, we're not really looking for too much to at those correlations. The main thing we're looking for with this correlation matrix is the bivariate relationship between our dependent variable and each of our independent variables, and also the correlation between independent variables between our independent variables, because we're looking to assess any risk of multicollinearity. I'll get to that in a second, but for now, let's look at the high confidence in education. Our correlations with our dependent variable. In this situation, we're going to use low confidence in education because we're going to use a logistic regression. Logistic regression predicts uh, um, one outcome or the other. So in this case, it's a dummy variable, presence of a condition or lack thereof, and which means we only can do one condition. We could do a multinomial logistic regression, which would allow all 3 of these options here, but that just gets everything a little bit more complicated. So to keep it simpler in this class, we're going to work primarily with logistic regression. So we're going to predict low confidence in education. We could predict high or we could predict medium, but just to keep our story simple, we're going to say that we're interested in what factors predict someone saying, I have low confidence in the people who run education in this country. So this is going to be our key dependent variables, low confidence education. So we're going to be looking for correlations here. So there's this negative correlation between no high school, low confidence education, negative between graduate and low confidence education. In other words, people with low high school seem to be less likely to say they have low confidence education. People with a graduate degree seem to be a little less likely. Now, of course, none of these have any significant or any test of significance here. So we're just examining the relationship in our sample, but just to get a sense of what our data are telling us. This is a first one to jump out here. We're seeing here that there's a large positive correlation between how conservative someone is and the probability that they say they have low confidence in education. Similarly, we're seeing a pretty positive correlation here between the probability that someone says they have a low trust in others and having low confidence in education. However, it seems like people who have low trust and low trust in others also have low confidence in education. So political ideology both of our variables correlate. Both of our variables relating to political ideology seem to be having a large or a correlation with low confidence education. Similarly, man has a positive correlation with low confidence. Woman has a negative correlation with confidence. And we can keep scrolling down where we find low. Yeah, I guess that was most of it, right? Yeah. All right. So the other thing we're looking for is correlations between our independent variables. Now, of course, we expect correlations between our independent variables that are the same subcategory. So for example, we'd expect an association between associate's degree and no high school. They're both variables that correspond to the same underlying variable. So we're going to expect them to have a high correlation. It's not going to be much of a problem. What is going to be more concerning are correlations between our independent variables that we are modeling to have an independent effect on low confidence in education. Independent effect, meaning the effect of one should be separate, or not the effect of one independent variable should be separate or distinct from the effect of another independent variable on the probability that someone has low confidence in education. And when you think of this in simplest terms, we're trying to predict what makes someone have low confidence in education. And if we're using two factors that are very highly correlated, in other words, someone's response to one variable is very similar, is going to be a very highly predictive of the response to another variable. It's going to be hard for our model to disentangle how much of the predictive power or how much of the effect on low confidence in education can be attributed to one of the factors and how much of it can be attributed to another factor. Um, uh, one, I guess one example we could think of this is uh, if we're trying to predict heart health using um, well, I went through a few examples. One example is if we're trying to predict heart health using weight and also height. So we may expect each of these factors to have an independent effect on each other, and that people who are taller are going to have lower heart health. Their heart has to travel blood farther, and people who weigh more are also going to have a negative effect on heart health, as especially um, uh, uh, oh my God, due to fat buildup and other dietary factors as well. So the question is, however, if we want to parse out both of these variables' independent effect, the regression is going to struggle a little bit because those factors are going to be very highly correlated. In other words, people who are taller just generally tend to weigh more. So it's going to be tough to predict how much of heart health can be attributed to height and how much of it can be attributed to weight if those two variables are very highly correlated. In other words, because people who are taller are generally going to be weigh a little bit more. So this is going to lead to inflated standard errors. It's going to decrease our ability to or it's going to make it a little tougher for us to make inferences. So it's going to inflate our standard errors and consequently inflate our probability of a type 2 error. So it's not the end of the world, but nonetheless, it's something to be aware of and to at least be on the lookout for. So we're going to identify potential issues with multicollinearity as a correlation between two independent variables that are modeled as having independent effects on the dependent variable that is greater than 0.1. So correlations between our independent variables greater than 0.1. Uh, and those independent variables should not be of the same underlying, like part of the same underlying variable. All right, so let's see if we can find an example. So let's look at some correlations with high school. So this one here, for example, there's a large negative correlation between income and high school. In other words, those who have a high school degree earn less on average. This is a correlation greater than 0.1. So in other words, it's going to be a little tough to disentangle the effects of high school and the effects of real income because people whose highest degree is a high school degree make less money. So it's going to be tough to disentangle those effects. So this is the evidence of potential multicollinearity. Here's another one. Oh, this is similar with education. So there generally seems to be a correlation across the board between education and income. So that's a cause of concern for multicollinearity. Any other ones we're seeing here? What's this? Women are more likely to work in education. And women in our sample are also more likely to have children. Um, so it seems like experience in education generally. Women are also not too much more likely to be college grads. So it seems like this may be some more evidence of potential risk of multicollinearity. Now, greater than 0.1 is just something you should make a note of. If you've seen correlations greater than 0.3, but certainly greater than 0.5, then you want to seriously consider dropping one of those independent variables in your model. It's going to be very, very tough to part out those two effects. So if you have correlation greater than 0.1, you should make a note of it in your paper. It's potential risk of multicollinearity. Greater than 0.5, you should absolutely consider dropping one of those variables. Greater than 0.3, you have a little bit more discretion. If it's around that 0.3 area, or somewhere between 0.3 and 0.5, you may want to consider dropping it. Um, but it, I'll leave it at that's at your discretion. All right, down to our regression. So we're going to start by doing the way we're going to do this. We're going to do first going to have a model for each of the variables corresponding to each independent concept. And then we're going to finally go to our full model. And this is where I'll talk about the odds ratios and average marginal effects. First, we're going to predict low confidence in education given experience with education. We're going to measure experience with education using degree and whether someone at works in education. So there's two variables as part of this first independent concept that we're going to use as our independent variables in our model one. So we use GLM, we're going to use family equals binomial. This specifies logistic regression. Data equals my data set. Make sure you're using my data set, not the GSS. The reason for that is because we want to make sure we're using the same sample size for all of our analyses. That's really important, especially because if you have something like a filter question, which in this situation, we don't have a filter question. Oh, actually, we do. Um, work edu. So this is industry 10. This variable here measures the respondent's occupation. We only measured occupation. We could scroll over here as well to see. It's not even going to mark it as inapplicable. Give them no work, yeah. Um, so it's on all three ballots here. And we can really see this, especially if we go to we can do a table with it in our full GSS. And we'll just do a summary just to count out the total number. Uh, only 800 NAs, but I believe that this question's only asked of folks who is only asked of people that have a job. We're not going to ask someone's industry code if they aren't working. Um, I'd want to dig into that a little more before I said that confidently. But this, I believe, is a filter question. And the main point I was trying to get at here is if you use a different data set, let's say you use the GSS here, for this variable, because work edu is only measured for people with a job, only people with a job are going to be included in this analysis. In this next model here, we're only using variables about marital status. It may include those respondents who don't have a job if you use GSS, because it's going to draw only folks that have answers to these questions. So you're going to be working. You're going to be predicting low confidence education with a different set, with a different, not only different independent variables, but also an entirely different sample. And it's gonna mess with your ability to make inferences. It's gonna muddle your results. So you want to make sure that's why we want to make sure we're working with these same 957 people. We're very confident about who are we looking at, who we're working with. So specifically this 957, one, it's limited by who got what ballot, but it's also only limited to people who have jobs. So that's something to keep in mind as we're interpreting our results as well, is that we're only looking at people who have jobs. I believe. Uh, if I'm wrong, let me know if I'm wrong on that assumption. I should probably uh, uh just for the sake of this video, I'm gonna work from that assumption. But yeah, but I should you want to double check that a little bit, digging into the code book to look back. Okay. Anyway, so let's run this model. So first here, so this model's predicting low confidence in education, given someone how much the respondent's highest degree and whether or not they work in education. Note here, we excluded the dummy variable for for high school, meaning that high school is our reference category. For this variable, we never even made this variable, but we are implicitly excluding a variable that measures whether someone does not work in education. So we're comparing people who work in education to people who do not work in education. So that's the reference category. Make sure you're always leaving one of your categories out so you know who to compare from. Okay, so this is saying here, compared to those who do not uh, who do not have a high school degree, or compared to those who have a high school degree, those who do not have a high school degree are less likely to say they have low confidence in education. We know it's less likely because this is minus. However, this effect is not statistically significant. In other words, we can't be confident that there actually is a difference in the probability of having low confidence in education for those without a high school degree and those with a high school degree. Similarly, for associates are more likely to have low confidence in education than those with a high school degree. Bachelors are less likely and graduates are less likely, but none of these differences are statistically significant from high school. In other words, we can't make any distinction in the probability for low confidence education for any degree from those with a high school degree. Similarly, those who work in education are less likely to say that they have low confidence in education. However, that effect is not statistically significant as well. So we can't be confident that people who work in education have different opinions from people who do not work in education, or a different probability of low confidence in education from those who do work in education or do not work in education. Down here we have our R squared. This is scientific notation for, I wonder if I plug it in, we'll move it. Yeah. Um, for 0.002. So this McFadden is what we call a pseudo R squared. In linear regression, the R squared has a very simple interpretation, which is the proportion of variation in y that can be accounted for by all the x's. The portion of variation are dependent variable that can be accounted for by our independent variables. And we can't calculate that as easily in logistic regression. Instead, we have a pseudo R squared, which we can still interpret in the same way as a proportion of variation in y that can be attributed to x. But you just want to be a little more cautious and at least to mention in your paper and your write-up that this is not it's not as clear cut mathematically as with the traditional R squared in ordinary least squares regression. So the way we'd interpret this is to say that in our simplest term, someone's experience with education predicts around 0.2% of the variation in the probability that they have low confidence in education. So in other words, not a lot of our variation in the probability of having low confidence in education can be attributed to experience with education. So only around 0.2%. Okay. Family formation. So we have two variables here. Notice our reference category is people who are married. So we'd say this, compared to people who are married, those who are never married are more likely to have low confidence education. However, that effect is not statistically significant. So we can't be confident there's a difference between married people and never married people's probability of having low confidence in education. Similarly, compared to those who do not have children, our reference category is no children. Those who do have children are more likely to have low confidence in education. However, this effect is not statistically significant, so we can't be confident there's a difference in the probability of low confidence education for those with and without children. Similarly, our R squared is around 2% of our variation. Around 2% of the variation in the probability of low confidence of education can be attributed to family formation. Our third model here, we have political ideology. So we have two variables for this. First, we have conservatism. It's measured in an ordinal variable. So there's because it's ordinal, there's not going to be a reference category. Instead, we're going to interpret this as the effect for a 1 point increase on the conservatism scale. For our reference to low trust is going to be anyone without low trust. So we're comparing people with low trust in others to those who have medium trust in others and those who have high trust in others. So there's two implicit categories in our reference category for low trust. Okay, so now we're seeing some stars. We'll get to which indicates statistical significance at which I'll get to in a moment here. So first we'll look at conservatism. What this is saying here is that for each additional point in conservatism, or the more conservative someone is, the more likely they are to say they have low trust in the people who manage education in this country. And this effect is statistically significant, which we can see because our p-value is less than 0.05. This is scientific notation for move the decimal place 5 places to the left. So what this means here is that we're fairly confident that people who are more conservative are more likely to say they have low trust in education. Similarly, compared to those who do not have low trust in other people, those who have low trust in other people are more likely to say they have low trust or low confidence in education. Those people who have low trust in others also seem to have low confidence in education, are also more likely to have low confidence in education. This may be an example of one we want to look at that check out for multiclinearity. In other words, we'd want to see if there's a correlation between conservatism and low trust, which would be here and here. So actually, there's not a very high correlation between conservatism and low trust. In other words, it doesn't seem that so conservatives are more likely to have low trust, but um, it's not super highly correlated. In other words, both of these effects are likely independent effects. In other words, there's both conservatism and low trust have an independent effect on confidence in education, um, which is interesting. So low trust, people have low trust are in others, regardless of. So another big thing about this is regardless of how conservative they are, or across the range of how conservative someone is, or liberal someone is, people with low trust in education are more likely to have low confidence in education. So even for this would be the effect for someone who is liberal or for someone who is conservative. Low trust is still going to have a positive effect on uh, our confidence in education. And this effect is statistically significant, so we can be fairly confident that low trust, that the probability of low confidence education is different for those with low trust, even after accounting for or controlling for how conservative they are. Okay, next. Oh yeah, we had our R squared up here. Our R squared is around 0.03, so similar. So around 3% of the variation in the probability of having low confidence education can be attributed to conservatism. So larger than our previous two factors by a factor of around 10. So instead of 0.2%, instead of 0.2 or 0.3%, it's around 3% of the variation. All right, social status. This here is saying compared to men, women are less likely to have low confidence education. We're in model 4. This effect is statistically significant, so we can be fairly confident that the probability of low confidence education is different for men and women. Compared to those who are not white, those who are white are more likely to have low confidence in education. This effect is not statistically significant, so we can't be confident they're different. As income increases, the probability of having low confidence in education decreases. However, that effect is not statistically significant. This is a little surprising because up here, I believe it was a positive correlation. Or not surprising, but yeah, real income and low confidence. It's positive here. So in other words, on average, people who make more money are more likely to have low confidence education. However, after we account for uh, whether their gender and their race, because gender and race are correlated with income, then it's actually a negative effect. So in other words, on average, people with a higher income have higher probability of low trust in education. But if we account for people's gender and their race, then it's actually less likely that they have low increased income is actually less likely. In other words, if you look at the effect of more income among white folks and people of color, women and men, we're going to see that actually it's a negative effect of having larger income. Again, this effect's not statistically significant, so we can't be confident that there actually just is no effect at all. But this is an example of a meaningful um, control variable or a meaningful uh, change in the direction of an effect given given another independent variable. Okay, model 5, we're putting everything together here. So this is all the variables corresponding to experienced education, all the variables corresponding to family formation, variables corresponding to political ideology, and the variables corresponding to social position. So we're going to run this, and we're going to come up, and we're going to be, the main thing we're looking for here is what effects changed now that we're accounting for more factors? Did any of the effects change? Is the story largely the same? Was there any effects that were statistically significant that are no longer statistically significant after accounting for other factors? Are there any variables that are not statistically significant or that were not statistically significant but are statistically significant after accounting for other factors. Those are the type of things. Did any of the magnitude of the effects change or the size of the estimate change? We're going to talk about how to interpret these. These are log odds, which are a little tough to make sense of. But we'll talk about the interpreting the magnitude in a moment. But we're looking for mainly differences in our interpretations or in our findings from the previous four models, which assess the independent effect of each of our independent concepts. Okay, first looking at education. Seems to be a fairly similar trend, where compared to those with a high school degree, those without without a high school degree are less likely to have low confidence education. Those in associates, a bachelor's, or a graduate degree are all more likely to have low confidence in education. Interestingly here, this effect size is a little bit larger. It goes from 0.18 from um, where was it? Minus 0.07. So on average, bachelor's degrees were less likely to have low confidence education. However, after we accounted for all these other factors, a big one probably being income, it actually seems that that those with a bachelor's degree are more likely to say they have low confidence in education. So after we account for how conservative or low trust they are, et cetera. Um, it's now, in fact, again, the effect's not statistically significant, so we don't want to read too much into this. But nonetheless, we could this is like an example of something we that could be part of an inspiration for future research because we may have a this is a good point to note now. One of the common things that students will ask is, "Oh no, my effects are not statistically significant. What does that mean? Am I screwed? Do I need to restart my paper? Do I need to add more variables?" Now, this is part of the bias we have in academia generally towards effects that are statistically significant. So we have a lot of issues like the file drawer problem, where if we do a study and we find the effects not statistically significant, we just bury it. And also there's a lot of epistemological things to think about with why we're so, for lack of a better word, obsessed with statistical significance. Um, one thing I want to really emphasize in this class is that it's okay if your effects are not statistically significant because that still tells us something. It may not tell us something definitively, or we can't make any confident inferences, but it can tell us that our one of the most common things it can tell us is that our understanding of it challenges our understanding of the social world. So, for example, we may have had this idea that people with more college education are going to be more confident in education. In other words, the people who have the least confidence in education are people that have no experience with it. They just don't understand education. And what our findings here are telling us is that, well, we don't really find any evidence that for that to be true. In fact, it seems that those with a bachelor's degree, after we account for these other factors, are actually may even be a little bit more likely. Now, we can't be confident that they're any different from those with a high school degree, but it certainly is the case that we didn't find any evidence that those with the that it's just ignorance is the only reason that's driving confidence in education. The lack of education is the only thing driving a lack of confidence in education. So, effects that are not statistically significant uh, um, are still meaningful, are still important. You don't need to fret about it. It's just that changes the way you have to write up your results and what your conclusions are going to be. But it's very okay. Um, I'll make a note here that if all of your effects are not statistically significant and you have a high multiclinearity, or in other words, you have very high correlations, then remember that multiclinearity can lead to an increased probability of type 2 errors or false negatives. So that could be something to consider. If you have a lot of multiclinearity, dropping some of your variables may lead to smaller standard errors and improve your ability to detect an effect that is actually there. So just because the effect, so in other words, we're talking about this with magnitude in a moment, but just because the effect's not statistically significant doesn't mean that uh, there's not an effect, which means you didn't find any evidence of an effect. You don't have strong evidence that there is an effect or is a relationship. Um, but I'll talk about this bit more with um, practical versus statistical significance in a moment. Anyway, so the effect of education is fairly similar. Effect of family formations fairly similar, where both never married and previously married are more likely to have low confidence than those who are married. Those who have more ch have children are more likely to have low confidence. But the big differences that we're finding here are that more conservative folks are more likely to have low confidence. People who have low trust in others generally are more likely to have low confidence, and women generally are less likely than men to have low confidence in education. These are three big statistically significant effects, or the effects that we're able to distinguish from zero. Our R squared, around 4%, tells us that someone's experienced education, their family formation, their political ideology, and their social status predicts around 4% of the variation in the probability that they have low confidence in education. So our final pseudo R squared. Okay, now let's get into how so most of what we're going through these results, we were interpreting the direction and the statistical significance. Let's talk a little bit about how to interpret the magnitude of the effect. One of the things we're looking for the magnitude of the effect is how large of a difference is there. So statistical significance can only tell us how confident we are that there's actually an effect in the population. Remember, we're only looking at around 957 people that are only those who work in the United States, right? So it's already a non-representative sample. We're just trying to say, well, how confident can we be? Ideally, we want to say that of people living in the United States generally, which we're already limited by our sample constraints on by the sample selection that we um, imported with our filter questions that limited who's even included in our sample, our subsample. Um, but that's like the goal. That's what the statistical significance is telling us, is to what degree we can be fairly confident that we can generalize this finding to people in the United States generally. The other important thing is, well, how large are these effects? How large are these differences in the probability of having low confidence in education? Um, and how large the effect is can help us to know if the effects are actually substantively meaningful or should we care about it. In other words, if women are less likely than to have low confidence education, but like it's a difference in probability of like 0.23 to 0.24. In other words, 23% of women are predicted to have low confidence and 24% of men are predicted to have low confidence. Then even if that effect is statistically significant, there's some questions around whether it's practically significant. There's no statistical answer to practical significance, but nonetheless, you should look at the magnitude and interpret that as part of being true to the data and in your interpretations. Okay, so this first one here is going to give us the odds ratios. I showed in class how to do this by doing the exponentiate. If we exponentiate or log odds, we're going to get our odds ratios. So if we exponentiate the effect of low trust, we're going to get 1.79. Which we're going to see right here. So that's where we got those values. So this is the just the exponentiated values of the estimates of the unstandardized. We took the unstandardized regression coefficients, which we see in this summary, and we took the exponential of it to get to our odds ratios. Okay, so what this tells us here is if someone did not have low trust and they had an odds of 1, this would be the odds uh, of having low confidence in education for someone with low trust. In other words, so that's the simple interpretation or that's the mathematical interpretation of it. How do we interpret this in simple sentences? What we could say is that relative to those who do not have low trust, those who do have low trust are 79% more likely to say that they have low confidence in education. Now, this isn't an absolute difference, right? They're not like the difference does not go from 20% for those with or it's not like 80% for those with low trust or 100% for those with low trust and 20% for those without low trust, right? It's a change in the relative probability. So if the probability for those who do not have low trust is say 30%, or we can even just look at the baseline of this, right? Table, my data set, low CDU, just the raw, the baseline probability, marginal probability is around 28%, right? So 28% of respondents generally have low confidence education. This is saying essentially, if the probability that someone with high trust or without low trust was 27, then we take the 0.28 or 0.27 and multiply it by 1.79, and the probability will be 50% for those with low confidence in education, or for those with low trust. So if this was the probability for those without low trust, this would be the probability for those with low trust. So that's why this number is 79% greater. This number is 79% greater than this number. Okay. This is getting a little tough to wrap our heads around. So I want to do one more example of this, and I'll do a negative here. A negative here. So this one here. So this effect is negative. So this is saying compared to men, women are less likely to have low confidence in education by a factor of 0.7. So that's less likely by a factor of 0.7. Another way we could say that is that compared to men, women are around 30% less likely to say that they have low confidence in education. And that's because, again, if the probability for a man was 1, so if this was 1, then to get the probability for women, we do 0.28 times this. So if the probability for men was 28%, and the probability for women would be around 20%. Now, we'll give these effects larger and we can look at the average marginal effects. But I wanted to kind of give a sense of what it was we're looking at the odds ratios and how we can interpret them as percent change. But these are not absolute percentage point differences. These are not marginal differences. They're relative differences. So let's look at some of these other effects. See if there's any effects that are not statistically significant, but are they practically significant? So this is saying compared to those with a high school degree, those with a bachelor's degree are 21% more likely to say they have low confidence in education. Now, we could say, is this, so certainly not statistically significant. We can't be confident that these differences exist in the population. But whether that 21% is evidence of that we should look at future research on this is up to your interpretation. You could, for example, say, this is really interesting findings. I really expected that those who had a bachelor's degree or those with more education we're going to be less likely to have low confidence in education. I'm really surprised by that. I'd want to do more research into this. I think it calls for more research. In fact, it's a 21% change. An odds ratio of 1.21 indicates that there's might be significant magnitude differences between those with a bachelor's degree and those without a college degree after accounting for these other, and those with a high school degree after accounting for these other factors. So something maybe we want to look into more. Again, that's up to you whether this was practically significant. Whereas an effect like white, odds ratio of 1.02, around 2% more likely than non-white folks, is maybe, to me at least, this is signifying that there's not statistical and probably we know there's not statistical significance, and there's also unlikely practical significance, which could be interesting, could be cause for more. It doesn't mean we should do more research on this subject, but this magnitude here isn't jumping out to me as something that is particularly noteworthy. So this also, the other one here, is this 1.24 is the change in odds for each additional point of conservatism. This is where it can get a little tricky because if you were to say 3 additional points of conservatism, we couldn't just take this 24% and multiply it by 3 because it'd be a percent change off of a new baseline percent. So you still interpret it by saying on average for each additional point of conservatism, we expect the probability of low trust in education to increase by 24%. But that does not mean that a 2-point increase in conservatism will necessarily lead to a 24% or will lead to a 48% increase in the probability of low trust. See if I can estimate that. You could I won't deal with that, but I'll show an example here. So we come back to our log odds. We did this times 2, and then we exponentiated that value. This would be the estimated change for a 2-unit change. So see how it's quite different from 48, right? 53 is different from 48, and that's because after the first point change, the change the change is going to be the baseline probability is going to be a little bit higher. So if it went from 27% to 0.28 times 1.25. We're going to get to 0.34. Then we have 0.34 times 1.24, right? So we're multiplying this the probability. So if this is the probability for someone that's very liberal, they have a value of 1 for conservative. This would be the value for someone, or well, this would be the value, yeah, that should be 0 technically, but yeah, this would be the value for someone that has a value of 1 for very conservative, so it's going to have a different effect. Okay, I know we got deep into the math weeds on some of those, but that's just something I wanted to make sure we got with our odds ratios and how we can interpret it as a percent change. Okay, look at AMEs. So this is the average marginal effect, or the on average expected change in the predicted probability of having low confidence in education. Okay, so what does that mean? That means that on average, so we interpret this, is on average, going from having no children to any children increases the probability of having low confidence in education by around 3%. So we could say the on average, but that's one interpretation that many folks will say. The more technical interpretation is that uh, for any given value, for any given person, going from the change in the predicted probability for having no children and any children will be expected to be different by around 0.028, around 2%, 3%. So for um, so in other words, across the full range of observed uh, 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 um, going from having no children to any children increases the probability of having low confidence education by around 3%, holding all other variables at their observed values. I'll write this down. Other variables at their observed values. This is the key. I forgot to mention this. I'll do this when I do the video on interpreting. I don't know why I typed it like that, but odds ratios, we're still doing the same thing we did before. We can say holding other variables at their observed values. AMEs are not holding variables at their observed values. It's holding variables, are not holding variables at, I'm sorry, holding all other variables constant. AMEs are holding all other variables at their observed values. So it's average marginal effects. So this is the key here, holding all the variables at their observed values. For odds ratios, it's holding all the variables constant. For marginal effects, it's holding variables at observed. Okay. So that's how we interpret this. So this is saying, compared to those with a high school degree, those with the bachelor's degree are 3% more likely, or we predict they'd be 3% more likely to have low confidence education, holding all other variables at their observed values. Compared to those who do not have low trust, those who do have low trust are around 10% more likely. We expect them to be 10% more likely to have low confidence education, holding all other variables at their observed values. So marginal effects are another way. This is so this by marginal effects here. What we mean is that this is from the baseline probability. So in other words, if the probability for someone without low trust was what was our baseline? 27, 28%. Then the probability for someone with low trust is would be plus around 0.1. So 0.28 plus 0.1. The probability would be around 0.38. Now, the probability for someone without low trust is not being held at 0.28. It's being held at whatever the observed value is, the observed predicted value is for that one particular person. And you could actually get and get those particular numbers, which is a bit beyond the scope of this video and this class. But nonetheless, that's how we interpret these values here. So this is a little different here, right? So we saw women. So I'll just do one comparison here. So this is saying, compared to men, women are 30% less likely to have low confidence in education, holding all other variables holding all other variables constant, or they're less likely by a factor of 0.7. This is saying here that women are around 6% less likely to say they have low confidence in education, holding all other variables at their observed values. So they're 30% less likely is from whatever the probability is for men, right? So whatever the probability for men is, they're 30% less likely than that. And in the base number, it's around 6 percentage points difference, holding all their variables at their observed values. They're going to be very comparable here, and I'll just show that as the last thing I do here. Um, if our baseline for men was 0.28, again it's not, but if our baseline for men was 0.28, we multiplied that by 0.7, then our probability for women would be around 0.2. And we see here that's around 8 percentage points lower, and our predicted change is around 6 percentage points. So they're gonna be a little bit different because again we're holding constant versus holding at observed values. So it's gonna be a little bit different. But that's and really this one's for an increase from our intercept, which is a little bit different, but I just want to make sure we're seeing the difference between a marginal effect and an odds ratio change. That's the key thing I want to make sure we get the difference between. Okay. I hope this was helpful. I know I got a little bit in the deep into the deep end for these odds ratios and average marginal effects. You should certainly be able to interpret the significance and the direction of the effects from up here. You should also interpret some of the magnitudes of the effects from odds ratios or average marginal chain effects. Uh, you should also be able to interpret some of these. You don't need to necessarily interpret every single one for every single effect. But now you should have the tools to examine the magnitude of the effect as well. Hope you found this video helpful, and I'll be back in a little later to make table 1, 2, and the writing results. Thank you.